All right, let's start the session on RINA, on GENI. Thanks for coming. I should stay within this box. So my name is Ibrahim Matta, faculty in computer science, Boston University, and PhD students Yuefeng, who had led the prototyping of RINA that we're going to use today, and Nabeel, who is on the GENI project, working on the GENI project with us. So we have actually some hands-on experiments to do, and I hope everybody got to. First thing you have to do is to join the Proto-RINA project. So make sure you do that if you are doing the hands-on exercises. And then you will see under my slices, the slices that we're going to use. We actually pre-allocated already 2 slices, resources on 2 slices that we're going to use. So if you go to my slices, you should be able to see what they're called. RINA tutorial slice 1 and RINA tutorial slice 2. So we're going to assign you to one of the slices just to load balance the load on the 2 slices. So you'll assign a group, and given your group number, if you can stick with your group, then you can. That will help. You will actually be moving configuration files that are there already from a directory that is named group 1, group 2, and so on, based on your assigned group, and then we'll take it from there. So Yuefeng will go around, give you your assigned group number and the slice that you should work on. Okay, we have 2 slices. And how many actually are doing the hands-on exercises? As we know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15. Okay, so we actually planning for 15 groups. So that's good. So everybody can work on their own, I guess. Okay, so we'll go around and you'll give them. Yuefeng also will give you the handout for the experiments we have planned. We have actually 4 experiments, if we can manage to go through all of them. To illustrate some ideas or concepts from the architecture that we are talking about here. RINA architecture stands for Recursive Internetwork Architecture. All right, so while we are setting up, I will actually give a quick intro to the architecture itself. There is actually a 2-pager on the GEC website that we put up there that introduces RINA and the prototype and what you can do with the prototype. And also there is a more detailed set of slides that introduces RINA, talk about all the concepts that are there. So now I'm going to use a few few of these slides to go over some of the concepts, and then we'll actually do experiments to actually make them concrete, hopefully. I don't expect you actually to get all the details about this architecture because we only have an hour and a half here. But hopefully you get some taste and some concrete ideas about how it works, basically. And obviously, if you have any questions later, we can talk. All right, so this project is funded by, has been funded by NSF since mid-2010. And last year it has been funded by the GENI. Last year we got funding from the GENI project office to run experiments, RINA experiments, and also hopefully make it available, the RINA software, make it available so that people can also experiment with their own management applications or control applications. All right, so let me start actually. The motivation behind this work, as you might be familiar with some of the work on future internet architecture. But the motivation for this effort is basically that the internet architecture is fundamentally flawed. There is a lot of weaknesses in the architecture in supporting features like mobility, multi-homing, security, manageability, and so on. Right? So there has been a lot of effort toward fixing these problems, but also some efforts into trying to come up with designs from scratch. So if you design the internet from scratch, what do we get? Okay. If you are familiar with the literature in this area, many of these efforts actually still propose extensions to the current architecture. So I would say they're not really clean slate. So what we try to do here actually is really start from scratch. And the goal is to come up with a model or theory for networking. So we want to have come up with a model that is complete in the sense of supporting services and capabilities that we would like to support, and we find a hard time to support on the current internet architecture, and also try to have a minimal model, so a minimal set of mechanisms that we need to support these capabilities. So this is our attempt, the RINA architecture, and it's based on, go back to actually basic principles in networking. One of the principles has been actually stated in one of Bob Metcalfe's papers in the 70s, which is that networking is nothing but inter-process communication and only inter-process communication. And this is basically our guiding principle, the principle that we're going to use to actually build this RINA model for architecture. The next question, can we transition to it without a flag day? The quick answer, short answer is yes, we can, in the sense that you can actually deploy it on private parts of the internet or on your private data center or private network, and we can also overlay it on top of the internet. Okay, please ask me any questions, because I know you have to twist your brain a little bit and forget about TCP/IP to actually get what we are trying to do here. So it's not straightforward sometimes. All right, so this is what we learn in networking classes, right? That networking is a layered set of layers, 5 layers or 7 layers of distinct functions that we build functionality all the way to support applications, right? And the problem with this view is that there is really no building block, so that in the sense of, think of my favorite analogy is a Lego piece. So you want to actually have Lego pieces, different shapes, different colors, but it's still a Lego piece. And we try to be able to fit these Lego pieces together to form bigger blocks, in our case, wide area network services. Okay? So in the current architecture, we don't have this building block. We have this hourglass model where IP is at the waist, and it's providing a rudimentary best effort service. And so it's very hard to actually extend advanced capabilities of underlying network technologies all the way to application through transport protocols and application processes. If you also look at a major weakness of the current internet architecture is the naming and addressing architecture. We didn't know what to name, or we named the wrong things, which is basically the IP addresses are naming connections to the network, interfaces to the network, they're associated with the network you are connected to, as opposed to the process you want to talk to. Okay, so the IP address is actually a point of attachment address as opposed to an internet address. So these addresses, the IP addresses, well-known port numbers through which you can access application services, these are all have been exposed to applications, so we subjected the network to attacks. We hacked in the middle box, so-called middle boxes, firewalls, NATs, etc., network address translators. And we ended up building a network of boxes as opposed to networks of processes or communicating processes. And this is basically the key idea that we have in RINA. We want to build the networks of processes, communicating processes. All right, so go back to the computer science, basic computer science principles, which is basically divide and conquer. And we know in operating system, how do we make application processes talk? We use the service of the operating system, the IPC service, inter-process communication mechanism. That's basically how application processes talk to each other. In networking, we'll talk about the distributed IPC facility or layer that will support the communication of application processes, right? So this facility is, think of it as a distributed facility. We're talking about networking now. It's a distributed facility, and it's basically a distributed application of processes talking to each other to provide communication service or IPC service to the application processes. So this diff, remember this term. This diff is actually our building block, okay? This is how we actually build networks of processes to support communication. How this diff is managed is internal, and it's not exposed to applications, so you can inherently have better security. We will use another concept from computer science, which is recursion. So basically what we are saying here is that your communication processes that make up this diff can themselves act as application processes and recursively ask for service, communication service from lower layer diffs, okay, or facilities that we are talking about here. So we can actually scale better because we can actually, as you'll see, we can have many levels of control. And then the building blocks, the Lego pieces have to fit together nicely, right? So this is basically we have well-defined service-based interfaces for communication interfaces. All right, so if I go through this recursion, okay, we have the base case of the recursion, which is basically this zero-level diff layers or blocks. Okay, so these are the building blocks. This is a recursive function, which means that you will have the same mechanisms. They're doing the same things, but maybe a little bit differently. So like Lego pieces have different colors, different shapes. We'll have that. This is what we call policies. So we parameterize the mechanisms to actually do possibly different things based on the kind of communication service you are trying to provide to the higher layer processes. Okay? And so this zero-level diff is actually at the bottom. This will be actually, imagine this is the end of the recursion. Right, so this is basically, there is communication here between these guys over some underlying communication medium here. It could be a physical wire. If it's overlaid on top of the internet, this will be possibly a UDP connection, a TCP connection. So you can actually run it as an overlay over the internet as well. And then we can build higher layer diffs recursively using lower layer diffs. All the way until we support application processes. So these are distant application processes. They'll be talking through this guy. So they'll ask this lower layer here for communication, IPC service. So this guy will establish a flow to the remote application process. This flow can be recursively supported by lower layers. Okay. All right. So that's the basic idea. So if I wanna impose this view over this traditional TCP/IP architecture. One way to look at it is that I can imagine I have diffs to manage communication over individual domains or networks or links. And then these red circles are the processes, the communicating, what we call IPC processes. And then they have higher layer diff building on top of that. So these actually dotted line here, these are virtual links, which in some sense communication services provided by the lower layers, right? So these guys will establish some flow there that provide this service to the higher layer processes, okay? How is that different from the current internet? First of all, we don't have to have these only 2 levels. We can actually have multiple levels, as you can see from this picture here. I have parts of the network where I have multiple levels of diff layers because I want to exercise more control over that part of the network, for instance. What goes inside the diff is actually all what is needed to manage a network. Think of it as a private network. So you have to have actually everything you need, including routing, transport, management tasks. And this view actually will change things for us. So the principles that we learned when you learn about TCP/IP, end-to-end principle, where you only the hosts can ask for service, this is no longer relevant. Here in this architecture, any process can actually ask for, or the ends of a virtual link are actually asking for service from the lower layer diff. So you can imagine that everyone could potentially be an end for communication. We don't need IPv6 and things like that because each diff level will have its private address space. Okay, so you assign addresses to processes inside the diff. You don't need a global address space. You will need a global namespace if you want to reach services, remote services, but you don't need a global address space. All right, so this diff block is a bunch of IPC processes talking to each other to provide IPC service to the higher layer processes, right? Communication service. What each IPC process will do is 3 sets of functions, mechanisms that are happening at different time scales. So we'll actually divide up the functionalities vertically as opposed to horizontally as in the current architecture. Horizontally, where you have this fast, basically all the mechanisms that are related to sending a data packet out. So the fast time scale, what we call tightly coupled mechanisms. And then the control is next, which is a bit slower to control the individual transmission for each connection going through the diff. So that's transmission control, error control, flow control. These are optional. I mean, you don't have to have them if you don't need reliability, etc. And then you have the management. So the management for us is basically applications here, includes routing, resource allocation, locating applications, monitoring lower layer services, and so on, that are running over using a common distributed application protocol that allow them to access management objects. So we are talking about routing objects if you are talking about a routing management application, or access control lists, or flow objects, etc. Okay, so they're all using one common protocol here, application protocol, to object-based protocol. And there is this RIB here that decouples everything. So this is the database. We call it a RIB, resource information base, generically speaking. All right, so we have basically to worry about 2 things, data transfer and management. For management, we have only one protocol. For actually data transfer, we only have also one protocol that we parameterize, policy-based. Depends on the type of service you need, that you need for that flow, for that connection that you are supporting. All right, so talking about naming and addressing. So I mentioned that naming and addressing is not complete in the current internet architecture. So here what we are doing is, in some sense, we name processes, not interfaces. Okay. So if I want to send something to Bob, this is an application name, the diff layer will have to have a connection to B. B is the IPC process that actually, underlying IPC process to that application that can get you access to that application. Okay? So we'll have to do, the underlying diff will support that kind of communication by mapping application name to a node address. So these node addresses are internally assigned inside each diff layer. Okay? So think of it again as a private network. And then for this guy to send a message to B, recursively, it will use an underlying flow or connection provided by the lower layer. So this lower layer will have to map B to some node address or process address inside its own diff layer. Okay. So basically, this B here, this is the process address in this diff. P is the process address in this diff. P is viewed as a point of attachment for this guy, B. So the addresses actually, think of them as relative addresses, not static as in the current internet architecture. So this is a node address here is actually viewed as an application, as a name from the point of view of this lower diff that needs to be resolved to a particular node address. And this name is also actually is a point of attachment from the point of view of the higher layer diff, right? So there is a relative actually addressing going on there. And this B and P are actually are running on the same system, running on the same machine. They just subscribe to different diff layers, okay? All right, so here, if I want actually B to talk to A, so or A wants to talk to B, what do we do in our architecture? So, and this, imagine B is actually connected to a private network, and A is on the public internet. In the current architecture, we put a NAT here, a network address translator, that will actually map the private connection to the public connection to allow communication. And we know that this broke a lot of applications, peer-to-peer applications. People didn't like the NAT because they deep packet inspection, they look into the private information, the transport level information, etc. So I will not bore you with that. But basically, what in our case here in this architecture, we support that dynamically by actually trying to establish a higher communication layer here, a diff layer, that spans both these networks. So you think of these as lower layer diffs or communication services. And I want to build something on top here to allow A and B to talk to each other. All right? So I'm going to start with a relay application that will initiate the formation, dynamic formation of a higher layer of communication. So this relay here, B, in this case, B will start. So this relay will be also the manager of this new layer of communication. So it will join this diff. So you can see that there is an enrollment. So they'll authenticate each other. So you authenticate that you allow this guy to join this communication layer. You initialize this guy with the policies of that layer. Policies include how you do routing, how you do addressing, etc. And then A can join as well. Okay. So there is an explicit enrollment procedure that we go through to build dynamically this communication layer or this diff layer. Okay. Now once we have it, we can actually A and B can talk to each other through this establish a flow or allocate a flow between applications A and B, application processes A and B. Okay. So the flow allocation is actually in RINA is quite different from what we see in the internet. Okay. So it might require you actually to create dynamically is communication layer, this diff layer, what we call diff layer. Okay, and the addresses for your underlying processes will be internal to that layer, just to be able to efficiently route things within that layer. Right, and this is not exposed to the application processes. The application processes, all what they get is a port ID that will communicate through. But inside here, if you go deeper into the details of RINA, we actually assign separate connection IDs for this connection. We can have multiple connections associated with the same ports, so that actually, and we can switch connections under the hood, and so on. So we can have a lot of flexibility into managing the transport connections going on between the applications. And everything is dynamically allocated, including the port numbers. There are no well-known port numbers in our architecture. Okay, so there is no attacks on well-known ports and so on, port scanning attacks, etc. All right, so if I want to actually hear these two application processes want to talk, I have to go from the source process, IPC process, to the destination IPC process. What do we do in routing? In routing, we do routing using node addresses within that communication layer, diff layer. So this source IPC process will use that as a next hop to get to the destination process where the application process is, right? And at each step, what we are doing is we are using the services of the underlying diff layer to go to the next hop, right, recursively, right? So, given the node address at that layer, this lower layer will have a flow that maps this node address to a point of attachment or a node address at that lower layer, and this guy will do the routing to the next, actually carry out the routing to the next hop. Right? So recursively, we're going to use the flows or the connections from underlying diff layers. All right. So here, for instance, this is multi-homed. So this guy has 2 points of attachments here. I want to go to the next hop is the destination. I can easily go to the route to the destination process by using the operational lower layer diff or lower layer flow. Okay, so this prototype actually implements some of these concepts that we have there. It's a user space. It's easy to use, actually. You'll see is this one. This prototype is written in Java. There is another prototype being implemented by actually these guys here in Spain. A year ago, they have been funded to work also on RINA. So they're building a prototype as well. And we are cross-debugging with them, etc. So for this prototype that you'll use today, we have this what we call RINA node, where we have basically in a node you can have actually defined application processes that you have, IPC processes or communication processes at different levels, right? So we have this multi-level kind of diff layers. So this process is joined some diff. This guy is joining another lower layer diff, and so on. So this is all on the same node, all right? And this shim layer is just to adapt the base case of the recursion to make it run over Ethernet or over the internet or whatever. All right, so the implementation, if you go deeper into the implementation, we have the IPC communication process will have things related to the data flow, data transfer protocol, and things related to the management. And what you have, we have two interfaces that are important for a user to program different control and management applications, and write applications as well in general. So one is as you might expect, you have an interface that allows you to establish a flow, allocate, deallocate a flow, send, receive, register applications and services, unregistered services. Again, the flow allocation is different from the internet. Again, it might require you to actually build dynamically a communication layer that has a wider scope to actually allow you to communicate. They have another interface that allows you to write management applications. It's a publish subscribe interface that allows you to get timely information about management objects that you're interested in, routing objects, flow objects, etc. We have configuration files. So this is an example where you can say, for this particular IPC process, it will be instantiated with link state routing protocol, how you actually compute path using hop count or some other cost metric. All right, so that's actually get me to some of the experiments that will touch on some of these ideas. Mainly how diff layers form by actually enrolling, having processes actually enroll into this communication layer so that they can provide communication service to the application processes on top. So we have experiment that shows you, give you a sense of this enrollment procedure that we go through, okay? And we have experiments where you will dynamically form higher layer communication processes and also some routing experiments to see that there is adaptation inside the communication layer to support application processes and so on. All right, so I think you have this piece of paper. So actually, let me stop here and see if you have any questions. I know there is a lot of probably details, but at least any questions on the basic concepts and how does it work? Yes. Right. So if you have two processes that will need to communicate with each other, application processes, they have to have an underlying communication layer or diff layer underneath to support this communication, so they can establish a flow. If not, then we have a directory service that we call IDD that you will see in the demos here. And this IDD service will register applications. So you might have applications registering to act as relays, right? The example I showed you there. So I could actually give you the name of a diff that you need to join. Or I specifically give you the address or the application that will act as a relay, and also the manager of a new diff that can get formed dynamically. So we have a directory service to support this dynamic formation of diffs if one doesn't already exist, okay? So if there is one already exists, you can use it. If not, then you might actually form a higher layer diff, wider scope diff for that. Any other questions? Yes. Right. Yes. So the key idea here is each diff layer has its own routing, own management, right? So yes. So the routing at different layers are independent. Okay. Each one have their own routing. Each layer has their own routing using the processes of that layer. So basically, right. So this is the right. So I'm routing. I'm exchanging the information within the layer itself. Okay. So we have this interface that allows you to subscribe and unsubscribe. So you can publish, for instance, if I'm talking about link state routing, I'm going to publish my link state information, and you subscribe to link state information. So in this case, everybody subscribe to link state information from everyone, right? This is if I do link state. If I do distance vector, then I only publish, subscribe only to distance information or routing information from my neighbors only, and so on. So this is basically the policies that we are talking about. So you can actually write different kinds of routing policies based on the information you publish and subscribe to. Yeah, so this routing here, so you can build routing here. Think of it as just a private overlay network, right? And you are using the addresses within the layer to communicate. This connection here between this guy and its next hop, its neighbor, is actually a virtual link, which is nothing but a underlying flow provided by the lower layer recursively. Okay?
So you mentioned the addresses are private. How do you assign them if it's an inter-domain communication?
So this guy here assigns its own addresses, right? So here you have your addresses here, right? When you join the layer, you get assigned a unique address within that layer, okay? And this is all what I'm doing. I'm routing across my layer, right? But I know that to go to my neighbor, I have to use a lower layer diff. So I'm going to do that. I'm going to actually have a flow established to my next hop, and I've just sent my information to the data that I want to send through this flow to my next hop. That's all. The lower diff will establish that flow by taking this node address and treat that as an application name, map this to a particular point of attachment, which is a low level address, and establish that flow for me. And this is done recursively, right? So this guy could be actually using a lower layer diff and so on, right? So there is no inter-domain. You are floating on top of lower networks or lower layer providers, okay? So each one can actually, there is no BGP, for instance. You can not use BGP. You can just use link state routing within each diff layer, okay? You just have to decide which lower layer providers or diff to use, okay? So there's no BGP, no instability that comes with BGP, and mess that comes with BGP. All right. Any other questions? We can talk, of course, more offline as well. All right, so the first experiment, hopefully it goes well. just to show you the enrollment, right? So this is, if you take the first handout that you have, if you are doing the experiment, and this will give you hopefully a better feel of what's going on. So we have node 1 that will have one IPC communication process, IPC1, and it will be the initial member of that diff1. Okay, so it will be actually the first member in that diff. So this will be, you will see that in the configuration files for the RINA nodes that we have. Okay, so this node 1 will be running, we'll run it on one VM, virtual machine. Okay, and it's configured to have this, again, this IPC1 that is the first and only member of diff1, communication layer diff1. And then we will start another node, node 2, running on another virtual machine. And it will be configured to have one IPC process, IPC2. And we actually, in the configuration file, we say join diff1. Okay, so I'll actually have IPC2 join diff1 by sending an enrollment message to IPC1, getting authenticated. And you can see the policies of authentication. In this case, we are using simple username and password. You can actually use more sophisticated authentication policies. But basically, this guy will get authenticated by IPC1, initialized by policies for that diff layer, which is could be what routing policies should I use, and what address I get assigned an address that is unique to that diff layer as well. Okay, and that's it. This is the first experiment for us. So we'll go over the enrollment procedure, where IPC2 is joining diff1. Okay, so you'll see actually you have messages being exchanged to connect to this diff, enroll to that diff, and it's using our common distributed application protocol that I have there to exchange enrollment objects around. Okay, so Nabeel will actually go over what you need to do. It's also in your handout. So can you bring the terminal there? All right, so the first thing you need to do is make sure that you can see your assigned slice on your, from the GENI portal. You can see your assigned slice, slice 1 or slice 2, depending on your group.
So there are 4 people that I just got to know who have not joined Proto-RINA.
Huh?
So
you can see only 4.
So there are 4 people who have not joined Proto-RINA project.
Oh, 4 people who have not joined. Okay, so you need to go to the.
So anyone who has not joined, so we can group them.
Is this on?
Can you guys hear me at the back?
Yes, it's on. Okay.
So there are 4 people who have not joined Proto-RINA. So if you go to your projects here, click on projects, you will not see Proto-RINA here. There are 4 people. So who are those 4 people?
So you need to join.
So you are one.
Okay.
So you can group with someone who has already joined the project, because it takes some time to.
Oh, okay.
Take some time.
So can you group? I mean, if you are not have not joined, just
project?
work in groups of 2. We have 4 experiments, so maybe you can alternate experiments. Yeah. Hopefully, everybody will see what's going on there. All right. So you have to see Proto-RINA first, listed under your projects, and then you click on Proto-RINA, right?
Yeah.
And go to My Slices, and then go to the slice that is assigned to you.
Actually, just click on Slices.
Oh, Slices are all right.
Yeah.
Click on Slices directly. You should be able to see.
So you will see RINA tutorial slice 1 and RINA tutorial slice 2. Make sure you go to the slice which has been assigned to you by in the piece of paper that has been handed to you. So each person has.
I think that's clear.
Okay.
All right. So if anyone has any problem getting into the slice that is assigned to you, you just click on it. Actually, you don't have to click on it. You have to launch FLAC that is in front of the slice. So can you launch FLAC? Click on launch FLAC there. Yeah. Which one are you assigned? So click on the last one. Okay, so you click on launch flag for the slice 1 or slice 2, just to balance the load. Nothing will happen, but just to balance the load. So it will take some time to show you the virtual machines we have already pre-allocated.
So if you click on it, it will show.
So it will take some time.
So we have reserved resources for you. Don't change the resources. Don't do anything with them.
Don't delete resources.
Don't delete resources. So it takes some time.
So it's just listing the resources we have already for your slice. And you will see 5 virtual machines. Anybody got the flag up and running? Still loading?
Yeah, I saw some people.
Oh, you already got it. All right. Okay, some of you are ahead following the handout. Okay, so you got it. Oh, you didn't get it. So
Yeah.
you're supposed to get it first.
It's still.
One more. Well, if you can follow the handout, go ahead. All right, so this is, so you can see we have actually 4 nodes here that we're gonna use. Node 1, 2, 3, 4. So these will be RINA nodes, will be running RINA nodes. Virtual machines will be running RINA nodes with certain configuration about, do you have an IPC process, application process, what diffs should they join? And then we have another node in the middle here that is the directory service that I just mentioned, our directory service IDD that tells you, for instance, which diff you should join if you want to talk to this particular application, right? Okay, so let's keep going, I guess.
So let's wait for a minute. Once it turns green, everything is green, that means that you have it all.
All right, so for the first experiment, we are going to use node 1 and node 2, okay? And we, of course, have to start the IDD, the directory service first, actually. All right, so we're going to use node 1, node 2, and this IDD node there, the directory node there.
Also, while it's loading, just make sure that you have your keys configured properly.
Yeah, so make sure you have this, your key working.
What you need to do is you need to do SSH.
Can you make it bigger? Can you?
Okay, yeah.
Can you see in the back there? Okay, that's good. I think that's fine.
So SSH add.
/.ssh/ Okay, so you have to do this, add the key here.
If you guys have not configured the key, you have to add this. It will ask for the passphrase.
Everyone has this done?
So
If not, then you have, assuming you have used the GENI portal before, you should be able to just do this, add the key, and it should work.
Is there anything specific for these slides? Because I use
No.
it all the time. But these ones,
No, it's fine. It's fine. If you have used it before, it's fine.
but then it asks for my password when I accidentally one, so I'm guessing.
No, then you have to add this, do this again. You have to do SSH add, even if you have used it before. Yeah, even if you have used GENI portal before, try to run SSH add. Oh, all right, good. So you logged in on the nodes already? Oh, you're adding the key? Okay. It's
Use his username, the Nabeel, or
no, yours. Did you use GENI portal before? Do you know the passphrase?
yeah, but I didn't see anything. So I thought maybe I entered, but I didn't do the SSH add, but I went straight to the node. But no, this is
Oh, you already got in.
yeah, but this is not his username. This is my username. The one that I always use, like.
Oh, yeah, that's fine. That's fine. That's fine. No, that's fine. That's good. You logged in, right? So it should work then. It worked with you then.
Do you have to add the private key as well? I'm using the Windows version, not Linux.
No, you just have to do it once. Did you do it?
I'm
You logged in.
my private key.
Oh, yeah, that's fine. Yeah. You're already in. Yeah, that's exactly what you need. Yeah, you already logged into the nodes, yeah. So everybody should, if you manage to log in SSH to the nodes, then you are fine. So we need to, for this experiment, we need to SSH to node 1, node 2, and this IDD node, IDD DNS node.
I just did SSH add, then this.
You can just use it here, just Control C here, and then just. Oh, it got stopped. Okay, you need to go, can't resume. Yeah, type what you have. Home, tilde, yeah, slash dot.
So everything
SSH
set till here?
Dot SSH
Key set.
slash the GENI.
So my RINA
ID,
tutorial slice is still
ID.
running.
Is it ID? Yeah, ID. It's written here.
Huh?
Let me see. Where is the first, the pages before that? Before that too. I think it's ID something. Yeah. You remember your passphrase?
You shouldn't ask for
You
password.
remember your passphrase? When you created this key, private key, you had a passphrase.
So if you do
for
this,
it.
it shouldn't ask for
It's
password.
different from the password. It's specifically for the key. You remember it? Okay, then you have to create a new one then by going to do this again. These steps here. So go back to the portal and go to the profile and follow these steps. All right, we should
Need to be green and it's still,
huh?
it's still like loading. Flag is still loading.
Oh,
But I have another tab which is already open. I can use that.
then use that then. Yeah. if you have it, then yeah, then close this one.
So,
All right, so let's
so your flag should look like this with 5 nodes. So let's SSH into we will SSH into 3 nodes. Node 1, which is this one. Node 2, which is this one, and IDD DNS. So if you click on this button over here, and then click on SSH, you can SSH into node 1 now. So this is node 1. I will close the previous one.
just say do the same for node 1 and ID.
Yeah.
Just let's keep moving.
And do the same for node 2 and node IDD DNS. So I will go to node 2. I will SSH into node 2 now. And same for IDD DNS. So open 2 windows for IDD DNS. 2 terminal windows.
All right, so everyone has actually should have 4 windows, terminal windows open. 1 for node 1, 1 for node 2, and 2 for IDD DNS node. Because we need to run actually 2 processes there. So we need node 1, node 2, and this one. Need two of them. So do that twice for the. Did you do the add your key?
Yeah, I think I did the SSH from the terminal. Right.
Most people. The key problem, the usual key problem. Forgetting the passphrase. Okay. Hi. I remember you.
Is John Day still involved in the research?
Yes, of course. Yeah.
Sorry?
Great
So
idea.
IDD has
So
2
we have
screens.
similar
So this is also IDD screen.
in Germany,
I
also based
yeah,
on
please
building
open it
blocks.
twice. Because we will run
What is
IDD
it
and
called?
DNS.
Zonata
What do you
need
call
2
it?
windows for that.
Service-oriented network architecture.
Zonata.
Yeah.
Okay. I should communicate, exchange notes.
Yeah.
Yeah. Do you have a website for it? A project? Is it?
Yes,
You have
we a
information
website for
online?
we have a website for the GLab project in Germany. But I can send you some publications.
Yeah, that would be great.
Yeah.
That would be great. I'd be interested.
Card so that I can send.
It's Matta, just last name at bu.edu.
Okay.
Yeah, it would be great to hear about it.
So far,
So
everyone is here?
most people are have these 4 windows open. You are ahead. Yes.
Yeah, we have
It's,
4.
yeah. All right. Okay. Okay. So good. So Did you manage to create a new one?
Never asked about the passphrase.
Did you do an add? Didn't ask you for the passphrase when you generated it? It didn't?
No, I asked, but I
Yeah.
put a new one.
Yeah, just put this new one now. In the mem-
DNS. But you need to copy.
yeah,
all
just
the
put your new.
Never asked about the new one.
Hmm?
When you copy this, right? Copy
Yeah.
this.
No,
Yeah,
I
you
never
need
asked.
to, yeah, you need to
Oh,
copy
it
this.
didn't ask when you generated the key. It didn't ask you for the passphrase. Hmm. Hmm. Maybe just delete what you have already there, just in case. I don't know. Yeah. Okay, now create a new one. Go back to profile and create totally new one. Go to profile, yeah, and just do it again. Yeah. Might be confused or something. Yeah, it's just okay. Yeah, just put the dot actually. It says just put it in the home directory. Are you in the home directory already? Yeah, just.
My group is 7.
Group 7. Okay, so you write
Oh,
group 7. 7. All right, and then okay. So you should have it here. Okay, so you are set. So there you have your configuration files there under this group. Okay, so if you look here, so this directory has configuration, so you can continue with the rest. Now you are all set. You have to do that for yes, node 2 and the IDD node. Yeah.
DNS one.
Which one? Oh, this one? No, this
Only
one
for
is on the IDD DNS node. You need to run it twice because here is running the DNS, which is and is running our own directory service. I will explain, but you have to run these two on the same machine, IDD, and you have 2 windows for it. Yeah, can you open a SSH again to the same machine? Oh, here.
It takes a while to.
Okay,
No,
so
This is
you
running.
ran what here? The DNS. Now go there and the other window and run the
Okay,
IDD.
So run this one.
Yeah,
I see.
the IDD. Our yeah. You wanna?
Okay. So now you need to copy
Are you
those who
okay?
have
Or
not
is
done it yet. So copy
Oh.
files from users. Tutorial.
Why don't you take this one? It's easier.
Users, tutorial, master, and group. So there are a lot of groups. Make sure you take the group which is assigned to you on the paper, and copy this to your home directory, and do the same for node 2 and for IDD and DNS. Okay.
show the configuration right now.
Yes. So yeah, the time is. Yeah, sure.
Just to recap what we are trying to do here. Anybody has still problems with opening these SSH to these VMs? All right, so again, what we are trying to do here is have a RINA node running on each VM, one for this experiment, node 1, node 2, and we have the IDD DNS node. We have actually, we open 2 terminal windows so that we can run our own directory service, IDD, and usual DNS service, because this is running over, actually overlay over IP. So we need that. And then we are copying the configuration files that is from your assigned group to each one of these nodes, to each one of these virtual machines. And for instance, this is on node 1, right? What's the name of the file here?
Sorry?
What's the name of the file?
It's node1.properties.
Okay, so here this is node 1. And after I copied the configuration file for your group, you can actually go under configuration/exp1.
Yeah, it's here.
Right? Yes. So you go to your group number /configurations/experiment1/node1. And then if you look there, you will see actually the configuration file for that node or properties that says, can I see the file?
Yeah.
So this is saying, this is the name of the IPC process is actually IPC number 1. The name of the configuration file for the IPC process, it's a member of diff1, right? So this is the kind of information you have in the configuration file.
An IPC file. And now opening the IPC file.
Well, you don't need to go over that.
No? Okay.
Okay, so if you have your change directory to configuration/exp1, then we are ready to run the experiment.
Okay. So first we need to start IDD and DNS. So in the IDD DNS terminal window, you need to go to the IDD DNS folder, group x.idd.idd. So we are now, this is IDD folder, and let me increase this one also.
We need one terminal for IDD and one terminal for DNS on the IDD DNS node.
So this one is for IDD, this one is for DNS. Now we will run the, first we are running IDD, users, tutorial, master. So I'm going to run IDD here. So IDD is running. And now DNS.
All right, so again, basically what the IDD process will do is when IPC2 wants to join diff1, it will say, I want to actually join diff1. So it will get back that it has to enroll with IPC1, which is already in diff1. Okay, so that's what the IDD service is trying to do. It will just map the network or the layer that you want to join to a particular process that you need to talk to, which in this case is IPC1.
Right. So you can run IDD and DNS, and you can minimize it throughout the experiment. So
right.
we just
so once we run the IDD process and DNS process, just minimize the windows. We're not gonna need them again. They'll be running all the time to register new diffs and resolve names, basically.
So now let's go to node 1, and let's go to the folder for node 1. So you will go to your group, go to the configuration files, go to the experiment 1 here, and then go to node 1 for node 1 terminal and node 2 for node 2 terminal. So this is for node 1. So I went to this. If you look at this, so I went to configuration, experiment 1, node 1. I will do the same for node 2. Group X, and then configuration, then experiment 1 and node 2 here. So if you look at these, if you look at this folder, we have node 1 properties and IPC1 properties file. Now we'll run node 1 jar users tutorial master, and there is this RINA jar file. And we'll give it as an input configuration file. And node 1 is now running.
Okay, just a second. All right. Everybody managed to do that. So we're running node 1 that has initial process IPC1 that is already the only member in diff1. Okay, and then we run node 2, which has process 2 that will join that diff by enrolling with IPC1. Okay, that's what we are trying to do.
So we have run so far this node 1 with this, and we want the node 2 to join it. So now we go to node 2. User tutorial master RINA node, and we give it as an input node 2 properties. Now node 2 is going to join it.
All right, so you can see some logging information here that that has enrollment of IPC2 into this diff D1 by sending this enrollment objects to IPC1. And actually, if you look closer, there'll be routing tables being built and so on. So now we can communicate through diff1. IPC1 and IPC2 will be able to communicate to build routing tables and establish flows, etc. if you have an application running on top. Okay, so if you have done this step, anybody has any questions about what's going on there?
So after you have run this, you can stop this both node 1 and node 2. And now we are going to look at the log file that is generated on node 1. So everyone is here? Okay. So let's look at the log file at node 1. Sorry, log file at node 2. So if you, this RINA log, BU log is the log file generated. So we are going to parse it. users, tutorial, master, and log checker. We give it as an input log file, and the option is to give us the management packets that has been transferred between the nodes. So this output log file has been generated now, this one. And if you look at this file, it has a lot of information.
All right, so guys, maybe we can try to do one more experiment to establish a flow.
Sure.
Next one. So you can see here just one quick note here. If you manage to come to this step where you look at the log file, you can see the enrollment procedure itself, and you can see that this node here got initialized. The authentication policy here is username and password. You can see it got assigned an address, which is 11 internal to that layer. And these messages can connect and create as part of the procedure enrollment protocol that we have. All right, so let's now go to the next which is just an extension of this one.
So, sure.
All right, so the next, so this is just showing that for this new diff layer, for this diff layer, there is an enrollment procedure to get initialized, and now in the next experiment, what we want to do is actually take it a little bit further up, and try to have application processes trying to establish a flow across the underlying communication layer. So in this case, we have node 1. We also configure it to have an application process on top. And this is the underlying communication process through which you are going to communicate with others. And then we have node 2 configured also to have another application process on top. So once you start node 2, what happens? There are two things. Will enroll first. So the underlying process, IPC2, will enroll into the diff first. And then you can communicate. So, and then the next step would be for app 2 to actually ask for a connection to app A. When you ask for a connection in RINA, you ask it by name. There is no IP addresses, no addresses at all. You say, I want the flow to app A. So the underlying diff will actually map this app A to IPC1, and then will allocate a connection, bind it to ports through which you can application processes can talk. And then you have a flow and with all the resources you need to communicate. Okay? So that's basically what happens in RINA. It's communication by name. You specify only the application name, no addresses, no IP addresses, no addresses at all. Say the name gets mapped to a process address. You establish a flow internally to the diff, and then you have a flow talking to each other. So in this experiment, we're going to run node 1 first, node 2 will run the enrollment procedure first to form the diff, and then app B will issue a flow allocate request, and then we can actually at the end we will see that they exchange messages. So we have simple applications where they just send hello messages to each other. Okay, so for this experiment, leave the DNS and IP will keep them running. Just go back to node 1 and start it again by going to the directory group / configuration / exp2 /
Group.
So now make sure you go to the directory that is exp2 / node 1 exp2 / o2. Right, so again the SSH to node 1 and node 2 again, and make sure you are in this directory that corresponds to configuration files for experiment 2. Okay, so everyone has node 1 and node 2 ready for experiment 2. If you want to run once you are on node 1 or node 2, if you want to run this, just hit the up arrow and get the same command to run the RINA node 2. Anyone has any questions?
Make sure you are in experiment 2 folder now. For node 1 and node 2. Experiment 2 folder. Just like here, I should.
log files with node 1 or node 2.
Yeah,
You see that?
yeah.
Some of them have this problem.
Mm-hmm. Yeah. So when you are checking the log file, check it for node 2, not for node 1, because node 2 is the one joining node, right? This is experiment 2. Yeah.
Going fast.
Oh, so that was for experiment.
Yeah, experiment to define the, can you first mention the log file?
Oh, yeah. For experiment 2, yeah. Yeah, for experiment 2, you have to use the log file at node 1, not node 2. For experiment 1, it's node 2. There's a typo in the handout 2. Experiment 2 handout. Should we go over this?
Some of them are going fast, some of them are slow, but
Okay. So should I
yeah, you can continue. Yeah,
continue?
yeah, you can continue.
So now I'm going to run the node 1 and node 2 for experiment 2. So if you just go up like up, but you will see the command that we already used for experiment 1. So you can just run the same command at node 1. And at node 2 again, we run the same command, this one. Now you will see at node 1 that you are going to receive messages. Hello world here, hello world 6, 7, 8, 9. And now I'm going to close these two nodes, node 1, control C, and node 2, control C again. And we are going to check the log file at node 1. Make sure it's node 1 for experiment 2. There's a typo in the handout. So we go to node 1 and we parse the, let me minimize this one, and we parse the log file. And give it as an input RINA log, and options is to generate simple app packets. So it generated a log file called simple app. If we look into this log file at node 1, so it received the messages and the content was hello world 0, 1, 2, 3, 4, 5, and so on. This is at node 1. So everyone is here till here? you have questions. Okay. For experiment 2. This is for the experiment 2.
Huh?
This is for the experiment 2.
Oh.
Yeah.
So I think
But we are, yeah.
can you get me the
Slides?
the slices running until I guess. Okay, so I hope some of you did the first the 2 experiments we had. So again, I should clarify a few questions I had. What's the role of IDD? What's the role of DNS? We had 2 processes. The IDD is our own RINA directory. So if you are asking to allocate a flow to a particular application, I have to tell you this application process is accessible to which diff layer. If there is don't have an underlying diff layer that you can use to reach the application, then I have to tell you it's accessible to this diff layer, which means you have to join that diff layer first. Okay? You have an underlying process, communication process, to join that diff layer, and then my application process can talk to the whole application process. Okay? So we have more involved things under the hood for allocating flows. DNS is just we have it to for the end for the base case of the recursion. But lower 0 level diff, we have process names. We are feeding the internet and the wire, so we're going to map this process name to an IP address and port number. So it has nothing to do with RINA itself. It's just to run RINA on top of the internet. It could map to real wire, it could map to Ethernet, VLAN, whatever communication layer at the bottom of the RINA layers. Okay, and I guess you can actually continue these on your own. The idea here was to go over the diff formation, and this would have clarified a little bit more the role of the IDD, our directory service. So, so I have here node 2, node 3 configured. All right, so here I have a situation where FB can talk to FA through this underlying diff. FA can talk to FC through this underlying diff. But if this guy wants to talk to this guy, they have to have a new diff layer gets formed that actually spans these 2 lower layer diffs. Right? So in this case, think of this as will act as a relay, or let's say relay application. So when you say I want to talk to FC, what I'll give you is actually give you this application. So this application name will initiate the formation of this higher layer diff by creating this IPC process. And these guys will create their own IPC process and which will join that diff. So now we have a new diff that has certain policies for routing, it has its own addresses, and so on. And now this guy can say allocate a flow to FC because I have now a communication layer underneath. I can actually use it to allocate a flow and reach applications. So here there is a new layer getting formed, and we have the enrollment, we have core application. And this last one was on our way to think, but hopefully that's some of the basic ideas.